so you should be able to pick it up again if you need to refer back to it at any point, or anybody who's got to dash off or whatever else can pick it up from our website. I'll just ask everybody to stay on mute throughout the talk if they can, and to put any questions in the chat box at the bottom, or we'll probably also have a Q&A session at the end where you can also ask questions as well. I think you're probably about 45 minutes, are you, Sean?
Yeah. I've not been through the whole thing in its entirety, but yeah, I don't plan to. It's certainly not my intention to be more than 45 minutes.
That's great. Well, that'll leave time for questions anyway. I mean, even if we run over a bit, we've got this room booked until 7 o'clock, although I certainly hope we're not still here then. I'm pretty sure you do as well. Anyway, right, without further ado, I'll hand over to you anyway and let you crack on.
Thanks very much, Pete. Hi everybody, and I'd just like to thank the regional group for inviting me along, giving me the opportunity to present this particular project. This particular ground investigation occurred over the past 2 years in a high-profile city centre location. I've entitled it Glasgow Quay Walls Ground Investigation, a Practical Example. My proposal is just to run through the key aspects of planning the ground investigation and what actually happened on site, what issues we knew about, what emerging issues happened during the site works, how we dealt with them, and maybe give you a bit of a flavour as to what the proposals are in terms of the actual final design. As I say, it's a practical example. There'll be no sort of groundbreaking research. There's no difficult equations in this presentation. Sorry to disappoint, but I also make no apologies for that as well. So I'll just move on to the next slide. So just I'll give you a brief kind of contents of what I'm going to present. So as I said, I don't anticipate this running more than 45 minutes. I'm hoping not anyway. I'll just give you a brief introduction to myself, who I am, what my experience is. I'll give you a sort of introduction to the overall project, key issues. I'll outline the site challenges prior to the investigation commencing, the background and approach to the ground investigation, why we selected particular techniques for drilling, a presentation of the actual results from the ground investigation, and outline what the actual results from the investigation has enabled for preliminary and also detailed design of the proposed new quay walls. There's also quite a nifty 2 to 3 minute construction animation video, which was made primarily to show the residents of the flats nearby the two locations as to what was going to happen. So that will hopefully play. That's 2 or 3 minutes, and I'll provide maybe a brief commentary while that's playing. I'll also touch on some other aspects that sometimes aren't normally considered during ground investigations, but there was some significant community benefits and social value programmes were undertaken. And then we'll finish with a sort of remarks, comments, question and answer session. So happy to field any questions, and if I can't answer you directly at the minute, I'll certainly get back to you with an answer to your question at the time. So yeah, just a briefer introduction to myself. Chartered Senior Geotechnical Engineer with Atkins. I've just got 12 years experience with Atkins. Joined Atkins in September 2008 and have been working in the geotechnical team since then. I've got experience particularly in long linear multidisciplinary projects, mainly in the roads and rail sector, and mainly focused in ground investigation and design. In the past 4 to 5 years, I've also entered into the dams and reservoir arena, and I'm hoping to become a supervising engineer in accordance with the Reservoir Scotland Act. In my role in this particular project, I led the ground investigation and input into the preliminary design stage, and I managed all aspects of the contract and investigative reporting. So yeah, just to outline what the project was about. So an introduction and project introduction and some aims. So give you a brief flavour. There's 2 areas of quay wall in a state of disrepair, and these are known as Anderston / Lancefield, which is one location, and a second location known as Windmillcroft Quay. So the aim of the project was to repair these two sections of quay wall that failed and or shown signs of failure and had been repaired temporarily. And the plan was to extend, the client's plan was to extend the quay walls up to 20 metres into the River Clyde to create space and public realm for urban development, with the overall aim to attract footfall and businesses back to the River Clyde, because there's been an emphasis on businesses relocating to the city centre away from the River Clyde in the past 40 to 50 years. And the project also forms a much larger scheme that Glasgow City Council are promoting at the moment for pedestrian connectivity and active travel across the city centre and to improve the riverside aesthetics. So basically, it's quite difficult to travel north to south and east to west across the city centre without having to stop at traffic lights or break up that particular pedestrian or cycling journey. And the aim is to be able to travel east to west or north to south across the site with very little pauses or breakups in those particular journeys. So just a brief kind of outline of the main project stakeholders that I'm going to cover. There's a vast amount of stakeholders involved, but I'll touch on the main ones. So we've got the overall client, who was Glasgow City Council and the City Deal. And the engineer and designer was ourselves, Atkins Limited, and special mention also to our principal ground investigation contractor on this particular contract, which was Structural Soils. It was very much a collaborative effort in delivering this particular package of works. And Atkins' involvement was from REBA stage 1 to stage 6. That's from sort of outline concept stage through to construction and then handover. We also had a desk study, a substantial ground investigation and its associated reporting, preliminary wall design, detailed wall design, and contract documents, tendering and construction supervision during the actual construction of the quay walls. So for those not too familiar with the centre of Glasgow, I'll just briefly touch on where these locations are. So Windmillcroft Quay, if you just to the bottom right of the picture that I'm sharing just now, is the Kingston Bridge, and we've also got what's affectionately known as the Squiggly Bridge, which is a pedestrian bridge just to the top left of the picture, and that bounds the site, those two bridges. So Windmillcroft Quay is a 330 metre linear length of quay wall, and that sits in front of what's known as the Windmillcroft Quay residential development, which is a set of, I think it's 200 to 300 sets of flats in this particular area. So it's a substantial development that the quay wall sits alongside. And also to the west of that particular stretch of quay wall, on the other side of the Kingston Bridge, which is now to the top right hand side of the plan that I'm showing you, is the Anderston Lancefield quay stretch, which is roughly a 710 metre linear length stretch of quay wall, so double the length of what we were looking at before at Windmillcroft Quay. And it's bound to the west, to the bottom left of the picture, by the Clyde Arc Bridge. So just to give you some idea of the project issues that we're facing, you know, what is the issues that we're facing here? Why are we doing ground investigation? Why are we redesigning the quay walls? So condition inspection results were undertaken following anecdotal evidence that was damage to the quay walls that have occurred progressively over a number of years and decades. The photographs that I'm showing you on the right hand side here, these were undertaken when Atkins did the condition inspections from a boat. And on the left hand side of the screen, what you can see is the actual original as-built drawings for the existing quay walls at Anderston and Lancefield Quay. Also a note to say that these original quay walls were actually constructed in 1838, believe it or not. And just to give you an idea of that, we normally design things, you know, 60 years or 120 years design life is normally what we talk about for permanent structures. You know, we are way beyond that now. going back to 1838. So these walls are now well beyond modern design life standards. So as you can see on the left-hand side, we've got the main makeup of the wall at Anderston Lancefield Quays, gravity wall supported on discrete timber piles, shorter timber piles, and then you've got a longer king post pile, which is then horizontally anchored back behind the wall. And what we're seeing from these condition assessments was that we've got the timber piles are actually starting to rotate. There's loss of the masonry blocks within the gravity wall, and we're also getting loss of rock fill that's been placed there as a temporary measure as well over the decades. In a similar vein, at Windmillcroft Quay, we've got a similar setup, not exactly the same, but we do have a gravity wall supported on timber piles again, anchored wall. Same situation, we've got loss of masonry blocks, the timber piles are rotating, and there's also evidence of shear within the steel bracings, and you can also see the deformation vertically in those timber piles as well. Again, same scenario with the design life. All the quay walls in this particular area likely to have been installed in 1838. And just to give you a flavour of what's been going on in these particular areas of quay wall recently, so this is Anderston Quay, so this is the section of quay wall closest to the Kingston Bridge. Quite striking failure photos here. So this failure occurred in February 2013. We've got catastrophic failure of the quayside wall, and you can see the substantial damage that's caused. There's potential. So what we've got is we've got a rotational failure of the quay wall, and that's likely due to the timber piles and or failure of the tie rods that I showed you in the previous slide. And then we've got, due to that, we've then got the riverbank exposed and then at risk of tidal erosion. So following on from that, a temporary repair was made by Glasgow City Council, and this particular failed section was reinstated with a revetment rock bund as part of a sort of semi-permanent solution rather than a concrete or sheet pile wall. So that's just an example of what can and could go wrong when these quay walls are left when they're not maintained. Again, similar to the Anderston and the Anderston failure, not quite as catastrophic. However, it was noted that sections of Windmillcroft Quay were at risk of collapse and potentially there was lateral and vertical movement underway, and a proactive intervention was then undertaken by the council to actually lower the earth behind the quay wall, which is exerting or showing signs of movement. And again, you can see on the right hand side, this picture here, we've got a sort of bowl shape that's been cut into the quay wall section that's most at risk, and this is to relieve the pressures on the back of the wall and hopefully to prevent a catastrophic failure similar to what we've seen over at Anderston Quay. The bigger risk here on this side is obviously we've got the residential flats here, and if a catastrophic failure was to happen here, this could have major implications on the foundations of the existing residential flats. So what I'll do now is I'll touch on Glasgow's sort of industrial legacy and why potentially the quay walls have ended up like they are, and what considerations did we have to take in planning for the ground investigation. So to give you an idea, there's for those not familiar with the Glasgow industrial boom, it was mainly focused around the tobacco and sugar trade, which rapidly expanded between 1700 and 1800s. And the Clyde itself was manipulated by engineers, James Smeaton, John Goulburn, and Thomas Telford. They devised ways of deepening the riverbed, and they used dikes and to channel the natural scour power of the water. And the parts of the upper Clyde were turned into canals. And just a few quotes there. Glasgow made the Clyde and the Clyde made Glasgow, and we've also got a quote there from one of the customs excise officers. Glasgow is checked and kept under by the shallowness of a river. Every day more and more filling or silting up. So the river, the current condition of the river is 5 to 6 metres of very, very soft silt under the riverbed, and that's been accumulating, and it's not really cleared, or it's not really been dredged or maintained or cleared over the past number of decades. But even back in this sort of 17th century, this was noted. So as we get further into the sort of industrial boom in Glasgow, 1818, foreign trading vessels could finally dock at the Broomielaw, so we can start to see a lot of the key. There was development at the city centre of Glasgow with these quay walls starting to be constructed, which ties in with the dates I mentioned earlier. 1838 with the quay walls being built at the Anderston and Windmillcroft quay. With dredgers and blasting, which continued to deepen the Clyde to accommodate even larger ships, and this enabled a huge expansion of the Clydeside international trade and a rapid increase in shipbuilding, such as John Brown Shipyard, which is a very famous shipyard. And also the shipbuilding played a vital role in the early 20th century during the First and Second World Wars, and the riverside was a target for World War II bombing, and there was a significant events in World War II, the Clydeside bombing, which I'll move on to later on when I touch on the issues that we had with undertaking UXO surveys for the ground investigation. So following that significant development, as you can see on the right hand side, it's much different to what you see today in Glasgow. Lots of vessels, lots of people, lots of activity, lots of trade. But there was a terminal decline during the 1960s, and now only a few shipyards remain: Govan, Scotstoun, and down at Greenock, which is further to the southwest from the locations that we've been talking about. And in support of the project that we're working on just now, the Clyde is now experiencing massive regeneration and trying to find a sort of new identity. Just to give you a sort of flavour of the historical development, I'll pick Windmillcroft Quay just as an example here. That was actually the Kingston, what was known as the Kingston sort of dry dock / where ships were constructed, and that's the actual location. You can see in the bottom left there, the Kingston Bridge is actually under construction, so this photograph must be from 1950s, 1960s, and where you can see the dock, that is now all flats. So the location that we are dealing with, adjacent to it, we've got an infill dock, which complicates matters for this particular project. That just gives you a scale of the sort of historical development that we were looking at, and the challenges that we had to face when scoping this ground investigation and to try and reduce risk or mitigate risk. So requirements for the investigation itself. To undertake the ground investigation in accordance with Eurocode 7, to satisfy the requirements for detailed design for the new quay walls, and to support that, we plan to undertake overland and overwater investigation locations. Very important thing was the depth study. I've touched on it before, and these are the sort of list of key potential things that needed to be mitigated against or thought about during the planning of the ground investigation, and the ground investigation had to be tailored to suit these requirements. So industrial legacy I've touched upon in terms of just the sheer amount of historical development. There's potential obstructions in the ground. We've got a UXO risk, which unexploded ordnance risk, which I will touch on later and show you examples of what we had to go through and to satisfy that. We've also got a liaison with a lot of third parties. There's a lot of external stakeholders such as SPT Fastlink. We've also got Glasgow City Council, we've got the residents, we've got Marine Scotland, but I'll touch on those third parties as well that we had to liaise with. had highly sensitive soft marine deposits, particularly on the overwater locations that we anticipated, so we had to plan for that. We had the potential tidal range during the overwater locations, and also may impact groundwater conditions for any of the land investigation boreholes. It's also a high-profile city centre location with numerous access issues, and on the right-hand side there is quite a good photo of one of the geosonic rigs being lifted over a flood wall with a crane because of the access was too tight to get that particular rig into the location that we wanted to investigate. And there's also the potential for crime being in a city centre location. So just to give you some of the, just a flavour of the project vision. So on the left-hand side here, we've got Windmillcroft Quay, and you'll see the quayside's been extended significantly out by approximately 20 metres as to what the original quayside sits at just now. And again, that's to create active travel and to potentially attract future businesses to the area. And on the right hand side, we've got Lancefield Quay, so artist's impression, again, same scenario. Create space at the riverside. There's a play park there, trees, soft landscaping, that type of thing. Improve the aesthetics at the riverside. That was the key aim. So the anticipated geology before we actually started drilling on this particular ground investigation, Atkins had undertook a similar project very close to the Brumulaw. It was known as the Brumulaw Quay Walls project that we'd worked on in 2005 to between 2005 and 2008. And sections of Quay Wall were regenerated adjacent to these proposed locations. So we had local knowledge and also, importantly, reasonably recent ground investigation information, including overwater locations, that informed and gave us confidence in what we were proposing at the time. And the ground investigation from that particular project was crucial in scoping. And it just highlights the importance of having good record keeping, data storage and information availability. And for those that are interested, here's the kind of anticipated sequence of strata that we were, the global anticipated sequence of strata across land-based and overwater locations. So we're looking at substantial thicknesses of made ground behind the quayside walls. And then after that, we'd be encountering alluvial sands and clays. The upper cohesive element of the alluvial clays would be very, very soft silt and clay. And as we go down beyond the alluvial deposits, we're expecting a slither 1 to 2 metres thick of glacial till overlying bedrock, and bedrock was expected approximately about 25 metres below existing ground level and approximately 20 metres below the waterline. So the actual scope of the investigation that we proposed for the most recent, for these two, for the Windmillcroft Quay and Anderston Lancefield Quay proposals were a UXO marine survey, 7 overwater cable percussion boreholes with rotary coring. It's interspersed with 6 overwater CPTs. We had 9 land-based sonic drill boreholes, 6 land-based CPTs, a handful of windowless sample boreholes and 2 machine dug trial pits. We also had in situ testing, dissipation tests, some seismic velocity testing and in situ standard penetration tests, geotechnical, geo-environmental laboratory testing, and we also added some continuous groundwater monitoring via data loggers to potentially pick up any tidal lags and the impact that may have on the design in terms of groundwater level. I'm not quite sure how clear this comes up for you guys on the presentation, but this is the investigation plan at Windmillcroft Quay. So you can see in purple, We have the land-based CPTs. So in this particular example, we had 2 behind the quay walls due to the potential thicknesses of made ground we anticipated up to 10 metres, and potential buried concrete foundations from old cranes and docks. We went with sonic drilling to penetrate these obstructions. That's what you see in the darker blue. So we had 3 sonic boreholes, and then over water we had 2 cable percussion with rotary follow-on boreholes and 2 CPTs in the sort of light blue slash cyan colours that you can see there. Similar on Anderston and Lancefield Quay, much larger linear lengths, so we've got more boreholes and investigation locations here. We've got, again, similar vein, we've got boreholes interspersed with CPTs. We've got land-based sonic boreholes, land-based CPTs. We have a couple of trial pits in areas of made ground on potential contamination locations, and in a similar vein, we've also got some window sample locations to try and pick up any potential sources of contamination from industry further north of the quayside. So, in terms of the added value that we brought to the ground investigation alongside our partners, Structural Soils, who were the principal contractor on the ground investigation, it was their recommendation to use a barge platform rather than a traditional jack-up platform, due to their experience drilling the Clyde estuary and in adjacent locations. And they were very confident in this method during the tender process. The benefits of this particular method, using a barge platform rather than a jack-up, was it saved the client in excess of £200,000 in comparison to other tenderers who'd proposed jack-up platform. Beauty of this particular technique, it can be assembled anywhere and floated up the Clyde, and more importantly, achieved clearance under the low-lying bridges such as the Clyde Arc and the Millennium Bridge, which at the time, although the Millennium Bridge is actually meant to rise up, it wasn't working. The mechanism for that bridge to rise up and let ships or vessels pass underneath, it wasn't working at that time. The ground investigation was being undertaken. We've also got manoeuvrability on site and between investigation locations. The jack-up platform is a bit more fixed in that aspect, and the barge can potentially get closer to quay walls than the jack-up barge may. The jack-up platform may. And it can accommodate all types of over water drilling, similar to the jack-up platform, so there was no drawbacks in that aspect. And like I touched on earlier, principal contractor Structural Soils had used this method successfully in the local environment, so it was a real win-win situation in this particular scenario to select the barge platform. Yeah, and as I discussed earlier, for the land-based investigation locations, that can specify sonic drilling in addition to CPTs, windowless sampling and trial pits, and this was to ensure that any likely obstructions from the industrial legacy, such as old foundations, concrete plinths, slabs, would not impede the investigation. It also ensures there was more certainty in the programme and costs from the start. There was less ongoing disruption to high footfall and trafficked areas. For example, if you had more certainty in programme, you wouldn't have to have as much traffic management, for example, for longer periods in a city centre location. We also asked for the CPTs to be pre-bored through the made ground, so the sonic drilling was also used to pre-bore the land-based CPT locations. And there was no reduction in sample quality using this method. And the beauty of the sonic drilling was it can also core rock, so it covered a range of potential scenarios. So in terms of just the ground investigation planning, I just thought I'd put in a couple of humorous pictures. is to we often get caught up in our little silos, and we don't really appreciate what everybody else is doing, and we focus on the details of and go into great detail in the particular tasks that we're undertaking. So a couple of messages to get across is that it was really important to undertake the desk study to understand what we were up against before we planned the ground investigation, and that allowed us to plan and tailor our techniques to suit the geology. We also ensured that all undertaking the desk study also ensured that all required consultations and consents were in place and were known about, and we could adequately plan and consent in advance, and there was no hiccups. It's important to understand what you're designing for, or at the very least the potential envelopes of possibilities. So at the time of the ground investigation, there was several options as to how the amount of intervention at the quay walls would be. There was always the option of a much simpler revetment design, or a sheet pile / concrete wall design, which is one of the more detailed interventions. So we had to ensure that our investigation covered a range of potential possibilities, and we had to understand that. I'd always advocate to get contractor advice. The ground investigation contractors are the experts, and designers are not always correct or have the relevant logistical experience to undertake the investigations. So take advice on board, and don't let other parties dictate the scope of the investigations unless they understand the implications. One of my colleagues brought up this quote a number of months ago, and I quite like it. There's never enough time to do things right, but there's always enough time to do it over again. That comes from Jack Bergman. Just a couple of pictures there that I decided to put up. Got it. Another colleague sent this to me a number of years ago. Here we've got the drillers on site filling up the cores because they've heard that they wanted full cores, and then the two guys below in the office taking that data and going into a lot of detail, and it's just an example of how we can get caught up in our little silos. So in terms of the external consultation for the ground investigation, you can see here we've got a range of parties involved here that required to be consented before the ground investigation started. We've got Glasgow City Council Roads and Bridges Department, got the SPT Fast Link, which was the dedicated bus lane that runs along Anderston Quay and further along towards the Clyde Arc Bridge and along at Lancefield Quay. We've got Transport Scotland, who have got interest in the Kingston Bridge, and if we are drilling or designing anything close to the Kingston Bridge, we decided to undertake some early consultation with them to find out what potentially their requirements could be, not only just for the ground investigation in terms of standoff and how far we need to be away from the bridge during drilling, but also for potential preliminary and any detailed design or any potential category 3 external checks that might need to be performed on that particular structure. We had to liaise with SEPA due to the proximity to the watercourse and drilling in and adjacent to the watercourse. Scottish Natural Heritage, now known as Nature Scot. We had Marine Scotland. We also had to consult with to get their permission, and they were evaluating whether we were potentially dredging the Clyde or not due to our drilling techniques, but that was ironed out in due course. We had the Crown Estate, and they own certain parts of the River Clyde, so we had to make applications to drill in their estate. Sections of the quay wall and also areas just beyond the quay wall into the water are also under the jurisdiction of Peel Ports, so we had to consult with them, and we also had the local residents associations at Windmillcroft Quay and Lancefield Quay, so we had the contractor, Structural Soils and the council, I believe, had to undertake letter drops to keep them informed of what was going on in the site activities, because obviously they've got real vested interest in what's going on, having seen the adjacent failures over the past decade or so. So again, diverging slightly, but the UXO, when we got to site, there was some emerging issues with regards to undertaking the UXO risk assessment. So it was identified in DESTA that there was a potential UXO risk, and Glasgow City Council sent us this drawing, which is a plan of the areas in Glasgow that have significant recorded bombing. There's two areas that I've highlighted with the white arrows: Windmillcroft, Quay there, which is in blue, and we've also got Anderston and Lancefield, Quay. So you can see there that we've got in the sort of hatched area that was unknown as to why that area was hatched, but there was records of, properties in yellow there. The key shows properties slightly damaged, exclusive of broken windows only. And then we've also got an area potentially in blue there, which is a potential actual hit along the Windmillcroft Quay wall there. So that highlighted the fact that we needed to take the UXO assessment a bit more detailed prior to starting the actual ground investigation. And in agreement with our principal contractor, Structural Soils, undertook a pre-site UXO risk in situ assessment, which was a magnetometer survey, which comprised of a small vessel going linearly back and forth, east to west, and then back west-east to cover the site to produce this particular map. And just to explain the results of this map, you can see in red there's areas where high readings have been captured, but these are also quite close to key walls, the sheet piles and structures for bridges themselves. So we've also got areas where, significant areas where blue has been recorded, and also there's pockets of areas of green and also red actually in the water area itself. So really the story is, from this assessment, was the results were inconclusive. This was either due to background readings or actual numerous UXOs in the ground, which we didn't think was there based on the initial depth study. So we couldn't really be clear on the findings of the magnetometer survey, nor could we establish a kind of, because of the readings were so close to each other, we couldn't really identify any clear zone areas, of sort of 20-meter diameter where nothing was recorded with any certainty. So the solution to get around that was we agreed to have down the hole magnetometer surveys for all over water borehole locations, and these were lowered, and readings were taken every 2 meters or so, up to a maximum depth of 10 meters below ground level in the river. And there was full-time specialist UXO presence from a specialist company at all times during these activities, supervising what we were doing. So to give you just a flavour of the actual results themselves, so I've just used Windmillcroft Quay only. Essentially, Windmillcroft Quay and Lancefield Quay produced the same sequence of strata. The snapshot that I've presented here might be a bit crowded, but I'll try and difficult to read, but I'll try and talk you through it. The grey/black upper areas are the made ground layer. It was then followed by a cohesive alluvium layer, and then it was then underlain by granular alluvium, and as I mentioned earlier, sitting on a slither of glacial till, which was overlying bedrock, described as the upper limestone formation, which was sequences of mudstone, sandstone, and I think there was a few areas where there was dolerite intrusions. So for the land-based investigations, we had made ground 5 to 10 metres thick, and then granular alluvium 20 to 25 metres thick, and glacial till up to 5 metres thick, followed by bedrock. For the overwater locations, the key difference and the key differentiator here was the absence of significant thicknesses of made ground. However, we did have 5 to 10 metres of essentially soft to extremely soft cohesive alluvium, described as extremely soft clay or silt. And this was underlain by granular alluvium, 10 to 15 metres thick, again, same glacial till thickness, 5 metres thick, overlain by bedrock. The results at Lancefield Quay were generally the same, with a marginally shallower bedrock encountered. So a couple of the unforeseen emerging issues during the investigation that had to be managed and were managed very well by the principal contractor, Structural Soils. The welfare location / hut was broken into. Minor kitchen items were stolen, but more importantly, there was evidence of a small party that happened overnight when that particular incident had occurred. We also had a small wheeled machine, I can't remember the exact details, either forklift or similar, that was stolen from the site and driven to a local park and set on fire. We had a potential asbestos incident noted in one of the trial pits. There was an operational stand down, and an asbestos expert was brought out to site to view the material, and the material was safely taken away and tested, and there was no further activities at this location until the results of that particular suspected asbestos material was known. What I would say is the windowless samples that were scoped around the Lancefield Quay area were largely unsuccessful, and this was due to obstructions within the made ground, which was expected. These holes were mainly scheduled for contamination purposes. There was also a host of buried services within the pavement, over and above what was noted on the service drawings. So these, and the majority of these boreholes, these windowless sample borehole locations, were actually abandoned or were cancelled due to these issues. There was one or two occasions where some drilling hours were lost due to low tide conditions, and awaiting the tidal conditions reversing. However, it didn't have a major impact on the ground investigation programme and was managed and mitigated very well by the principal contractor. Another issue we had was due to tight access close to the quay walls. We had it was suggested that we would use smaller CPT rigs to get close to the edge of the quay wall, and these needed to use water drums as kentilage to produce the reaction force that was needed. However, we found that even with the pre-boring through the made ground, we found that we didn't get enough reaction force or depth from these smaller CPT rigs to get down to the location of what we needed. And the solution was to reschedule some track-mounted CPT lorry locations and sacrifice the optimum positions, and that allowed us to gain the required depth that we needed to analyse the overall geology. I want to touch on some items that aren't usually covered during ground investigations themselves, or rarely, but seem to be coming to the fore more often in projects that certainly I'm working on, and that's community benefits and social value aspects. And both Atkins and also Structural Soils have ongoing commitments to these. And in terms of what Atkins have brought to this particular project, these are the commitments that we made to the client, which was new full-time job creation, 4 work experience placements, 2 graduate work experience placements, some career events, site visits, 2 small to medium enterprise briefings for supply chain purposes, a minimum of 10 hours non-financial support to the local community. An example of that's on the right-hand side, where members of Atkins staff undertook a beach clean, and a number of subcontracting opportunities had to be advertised. And in blue there, we've just got a quote from one of our graduates who the project allowed us to undertake, employ a graduate based on the workload that we were getting from that particular project. And then in terms of the things that I know that the principal contractor, Structural Soils, were doing, they did a great job in terms of bringing community benefits and social value to the project. They had 2 schools into their Glasgow office depot for lectures. We were also taken to the laboratory to see the drilling equipment and what they'd learned in the office during the lecture, and then they were also taken to site to see what was actually going on during the ground investigation. I thought that was a really nice touch from Structural Soils, and you can see some Twitter feedback there from the 2 schools, St Roch's and St Andrews secondaries. So just to touch, sort of coming to the latter end of the presentation now, and just to touch on what the potential design solutions are and what the ground investigation has allowed us to do. So looking at, I'll focus in on Windmillcroft Quay because that's the most advanced design at this particular point. Anderston Lancefield Quay is on pause just now, and that may resurrect itself in the future. However, I'll focus in on Windmillcroft Quay. That's the main focus for the client just now. And you can see the picture on the left is the existing situation, and the picture on the right is what they want it to be. So that's a 20-metre extension into the current quayside, into the current river, sorry. And originally we only had one solution, which was a twin sheet pile coffer dam wall along the entire length of this area. However, there was a bit of value engineering which we undertook, which was to identify where we could save on steel, which was the main driver for cost. And we identified that where there was gaps in between the existing flats, we could potentially have a longer anchored wall solution, which meant that we've almost got like a hybrid design, because one of the key constraints for pushing this wall out 20 metres is that you can't have long anchors which could clash with the existing piled foundations of the flats. So anywhere in between the flats where we've got sufficient space, we're looking at potentially doing this traditional single anchored sheet pile wall rather than a twin pile wall. The benefits of that was we've got a 2-metre reduction in king pile and sheet pile length. We've got removal entirely of the secondary strut section and a reduction in overall steel. And there was also a reduction of large quantities of imported material and double and triple handling of material during the piling process, much of which is undertaken in the water. So just to give you, so if you flick back there, we've got the blue section, the red section, and this corresponds to what I was talking about there, the traditional anchored wall section. We've got a single sheet pile wall in blue, and then we've got a long horizontal anchor tying back into a smaller anchored sheet pile wall. And then on the right-hand side, we've got what was the original solution along the whole length, which was the cofferdam double wall section, which doesn't have the long lateral linear anchor at the back due to the potential clashes with the foundations of Windmillcroft Quay flats. And to illustrate this a bit better, I hope this video will work. I'll let this play. It's about 2 or 3 minutes long, and it's quite a good illustration of what's expected. And this particular video was shown to the residents of Windmillcroft Quay at preliminary design stage to give them an idea of what's going to be happening outside their flats. Maybe go quiet for a couple of seconds, but I'll speak up when there's anything of interest, and I'll just let this play. So this is the beginning of the piling bund beginning to be formed. That section there is the coffer dam wall. You can see the close proximity to the flats. In this particular section, we're looking at the traditional anchored wall because we've got the space and we don't have the interaction with the foundations at the flats. And that process is just repeated along the entire length of the site. And then we've got the hard and soft landscaping and the completion of the project. So just to only 2 or 3 slides left, Pete. So just to kind of recap of the ground investigation itself, what were the successes? Well, there was many. This particular project was nominated in 3 categories at the National Ground Engineering Awards under Community Benefits, Ground Investigation Project of the Year, and Project of the Year under a specific value. There was excellent communication lines between Atkins and Structural Soils throughout, and any actions or issues that arose, there was responsive actions taken by both parties. There's also just general taking ownership. One of the things that stuck in my mind was Structural Soils proactively securing the site following a fence being damaged by third parties, and this was towards the end of the investigation and long after the main activities had stopped. So I thought it was a really nice touch. It was delivered within the expected budget range and delivered as per the anticipating an emerging programme during site. There's a wide range of drilling techniques, and these supplemented each other well. And in this particular job, due to the depth of the information and the geology, almost 2 types of scenarios. We've got land-based and over water locations. There was no one magic bullet technique that would be good for all situations. What about the lessons? Well, there's not too many, just a few minor points. I touched on the site security. Could we have had, full-time security? Possibly. This would have increased costs. But the compromise was to use the principal contractor's local office, which was less than 1 mile away after these incidents. And also we had the old Atkins office at the Brumelaw, We've just moved recently, but yeah, we had that overlooked, the actual site itself. The windowless samples, as I touched on earlier, they didn't work too well in the made ground, combined with the densely populated buried service locations, and also the light CPT rig with the water drum kentilage didn't really provide the necessary action forces where needed, and they terminated early. Next time, we would probably advocate the use of a truck-mounted machine if we were to do it again. So just presentation recap. So I've given you an introduction to the overall project and the key issues. I've outlined the site challenges prior to investigation commencing. I've discussed the background and approach to the investigation. I've given you a presentation of the site-specific results. Outlined what the ground investigation has enabled for preliminary and detailed design. I've shared an animation of the proposed construction proposals and touched on community benefits, social value, successes and lessons learned. And we'll move on to a question and answer session, I believe.
Yep, thank you very much, Sean. That's much appreciated. Thank you for pulling that together and for giving us the presentation. It was very informative there and great project. I haven't got any questions in the chat at the moment, but I've got a couple, so I'll start with those, and then people feel free to either drop something in the chat or to unmute and just shout out afterwards. But obviously, great example, as you've highlighted, of using multiple different techniques in the GI to based really around the information that you knew. But did you have any issue getting that through with the client, obviously in terms of a cost point of view? And then the second question, which is unrelated entirely, would be the social value elements that you mentioned. Were they mandated by the client, or was that something that came from Atkins and Structural Saws?
I'll answer your second question first. So yeah, they were mandated. So they were a key requirement within the contract themselves. But we had scope and flexibility as to how we deliver them. You know, it was we chose to do the beach clean ourselves and that. You know, so we had avenues to tailor that to what we wanted to do. And sorry, what was the first question again?
So that was really whether you had any issues with getting through things like the use of Sonic and CPT and that with a client, and sort of having, because I presume obviously that's perhaps, obviously maybe a bit more expensive than the client may be used to, or things like that, really.
Yeah, so the client, once we explained the risks, the key thing was sitting around the table with their client and just being open and transparent and telling them what the risks are. One of the things that also worked in our favour was, Structural Saws' recommendation of using the barge, which was significantly cheaper than some of the other tenderers. So we had a bit more leeway and scope in the actual price itself, because obviously that came in significantly less than some of the other tenderers. But equally, we had to be sure and discuss that with Structural Saws that particular method was suitable for the overwater locations, and they were confident, and we were happy with that. Happy with that approach.
Okay, that's great. It's good to hear as well. I think it's so we've been involved perhaps with things where we've done the wrong technique because it's been insisted on by the client, but actually in the ultimate, in the long run, becomes more expensive because you either have to come back again because it didn't work or for any other reasons. So good to hear that approach works. So we've got a question here from David Shilston, who says, great presentation, many thanks. My question is, the proposed construction method involves placing large quantities of fill in the river, then removing it. Why is this better than constructing walls from floating platforms?
Well, I would need to take that away and answer that one myself. I don't know the actual design implications of what was proposed at the time and why. I've kind of not been involved in the actual preliminary or detailed design of those particular elements myself, but I can certainly take that away. and get an answer to you, David.
Okay, I'll let you off that one. I'm pretty sure you can
Yeah.
get obviously David Atkins as well, so you can
yeah.
drop him an email or give him a call tomorrow on it. Okay, well, I haven't got anything from anybody else in the chat, but if anybody wants to unmute and jump in with a question, then please do. Okay, Sean, I think you've covered everything. So I want to say thanks again for giving us the presentation. It was really informative, and obviously, I think for those of us who are in Glasgow, Scotland area, local project. So really good to hear about that, and obviously good to hear that something's winning something nationally, I think, from Scotland as well. So appreciate that, and thanks all for joining. As I say, the recording will be up online if you want to recheck anything again. And,
just also thanks to, I think it was Scott Brannan who'd sent some photos through of his experience on some of he was working on a particular project. So I just want to thank him for sending some photos through. I can't remember if I used them or not, but it is appreciated they sent those photos through.
That's great. All right, well, thanks all. That concludes the evening talk, and I'll say look out for our website and LinkedIn for future events. Thanks all. Bye-bye.
Cheers.